Now, chapter 12, side problems, page 218. Try this problem.
Yes, okay, so we have this convex quadrilateral with these two opposite angles of 45 degrees, right? And we have that AD plus BC is 4. So I'm going to call this X and this 4 minus X. And what I see is that we have a side and an angle and also a side in terms of a variable. So it makes me think of this for any given triangle ABC with A, B, and X as the angle in between the two sides. We have that the area of the triangle is equal to A times B times the sine of X over 2. Right? So what I'm going to do is I'm going to use this on this triangle, DCB first, and I get 2 times 4 minus X times sine of 45 over 2. And then for the other one, the other triangle, DBA, we have 2 times X times the sine of 45 over 2. So we can cancel out the 2's, and we get, using the distributive property, 4 times sine of 45 is the area. Sine of 45, that's root 2 over 2, which means that the total area is 2 root 2.
That was the end of the page 208 side problem. Chapter 12, side problem, page 221. It is another area proof problem. So
Yes, okay. So we have df is equal to fc. So I'm going to call this A, B, B, 2b and 2a since it's a parallelogram. And what I think is that since we have this weird triangle here that we don't exactly know how to find the area of, I think we should find the area of the parallelogram first, and then find the areas of these three triangles here, and then subtract it. So, well, for the area, we're going to need to use the height. So I'm going to draw in the height right on the right side like this. And I'm going to extend this over to here, because that means that from this 1 to 2 ratio, B and B, so we have B to 2B is a 1 to 2 ratio, which means that H over 2 to H has to be a 1 to 2 ratio. So these has to be H over 2 and H over 2. So now we're looking at this triangle. So this triangle here, FEC, right? The area of triangle FEC, right? That is going to be equal to A times H over 2 over 2. So H over 4. Triangle AEB, the area of this triangle is going to be equal to 2A, because that's the base, times H over 2, and then we put it over 2. So in total, 8 times H over 2.
so which is double, right?
Yes, it is double.
If I
And then,
A, this is
yeah,
going to be
A,
2A.
2A.
That's good.
Now we have DAF, triangle DAF. The area of this triangle is equal to A times H over 2, right?
Which is as same as triangle
Same as triangle AEB, yes.
AAB. That's good.
And now finally, the area of DCBA is the big parallelogram that's equal to 2a times h over 2, which is no 2a times h. So 2ah. So this parallelogram ABCD is equal to 2ah.
Which is in terms of A, in terms of capital A.
Yes, it is equal to 8a.
Then what's the leftover part?
So this little part over here is going to be 3a. So we have the ratio is 3a is over 8a. So the ratio is 3 over 8. And that proves this.
That was very clear and concise. Nice explanation. Thank you. Let's see. That was the end of the page 221 proof. Now we are moving another nice side proof. Page 222, another nice area proof. Okay, let's see.
Yes, okay. Well, the difference between this one and the last one is that we have these lines drawn in, but they're on a different side,
Mhm.
right? So what I see is that we can draw in this and this. And if we say, for example, this is A,
Yeah,
right?
already giving, let's say S, right? Let's say.
Yeah. Yeah, this is S. And notice that since LBC, so if you know this, if you have a triangle like this and you have this median, because both of these triangles, they have equal bases and they have the same height, which means they have the same area, right? So that's S, which means this is also S. And now we have this, this is S, which means this is also going to be S. So, and we have from this, we have this is 2S, right? And since they're the exact same triangle, right? This is this triangle over here, DKL. If we flip it over 180 degrees, we get KBL. So this is 2S, which means that in total, this whole pentagon is going to be 4S. And all of the other S's, they add up to 12S. We have 6, 2S, 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 S, 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 2S. Adds up to 12S, which means that in total, 4S is a third of 12S.
Okay, that was good. Thank you. Chapter
Okay.
12, another side problem, page 229.
Yes, okay. So the nice thing about this problem is that we have these two triangles. We have this triangle over here, this triangle, ADF, triangle ADF, and then we have, since it's a square, this is 20, so we have this congruent triangle, DCE. So ADF, right, ADF is congruent to DCE. And what this tells us is that if we call this, for example, if we call this alpha, and this beta for triangle ADF, that means this also has to be angle alpha, this has to be beta. And if we focus on this triangle here, DEK, we have alpha and beta inside it, which means that the third angle has to be a right angle because alpha and beta add up to 90 degrees, right? So we know DF and EC, they're perpendicular. So what we're going to do now is we're going to use this in, because notice not only are these triangles, they're both congruent, they're both 3, 4, 5 triangles. So this is 20, 15, which means that this length DF here, that's going to be 25, right? But the good thing here is that, remember, this triangle also had alpha and beta inside it. So we can move it like this. We have, this is beta. And since this is a right angle here, this angle is going to be alpha, which means that alpha, beta, this is also a 3, 4, 5 triangle. The hypotenuse here is 20, which means that this is going to be 16 here. This is going to be 9. We have 15 and 20 here, so this whole thing should be 25. So that means that this part should be 9 in order to make it add up to 25. And yeah, my bad. This isn't 9. This is 12.
12.
And since this is 12, and the whole thing should be 25, this is 13. So KF is 13, KC is 16. This is a right angle, so we can just multiply it out. 13 times 16 over 2 is equal to 104.
8. 13 times 8, then the area is going to be 104.
Yes.
Good. Chapter 12, page 230. Another nice side problem. Let's see.
Yes. Okay. So we have this relationship between these two areas. So what does this relationship mean? Well, let's call this x and this y. We know that from DC being 9, we know x plus y is 9. And now we can use the area formula for a trapezoid. Let's just call the height an arbitrary number. The height can be h, right? So now let's find the area of DEFA, right? The area of that trapezoid is going to be x plus 8 over 2 times h. And the other trapezoid here, ECBF, it says that it's equal, and that is equal to y plus 13 over 2 times h, right? So now the h's and these divided by 2's, they cancel each other out, and we're just left with x plus 8 is equal to y plus 13. So we can use this along with x plus y equals 9 in a system of equations. So I'm going to subtract 8 from both sides, right? That. So now I can substitute x for y equals 5, y plus 5, y plus 5 plus y is equal to 9, 2y is equal to 4, and y is equal to 2.
That is exactly what we are looking for.
Yes, y is EC.
EC, which
So
is
yeah,
y equals
2.
4. Okay, this is, I think, chapter 12, page 231. Another side problem.
Yes, okay. So we have a right trapezoid, and we have these perpendicular diagonals. And what I'd say is with these perpendicular diagonals and this right trapezoid, we have this theorem from a couple of chapters ago that tells us that if we have x and y here, that x times y is equal to 4 squared, right? So we can plug this in. We get xy is 16. And now we can use this other piece of information, area of triangle BKC. So this is equal to 12 more than triangle AKD, right? So let's call this area A. This area is going to be A plus 6. And what I'm going to say is we don't really know a way to compute the areas of AKD and BKC, but what we can do is we can say this common triangle here that's adjacent to both of them, we can say that has area B. So now we have ADB has area A plus B, and the area of ABC has area A plus B plus 12.
So,
Yeah.
Andrew, the area BKC is, yes, 12. Good.
Yeah, A plus B plus A plus 12. So it still preserves it being 12 more, right? So we have that the area of this A plus B here, the ADB triangle, that is equal to 4 times x over 2. And the area of ABC, which is A plus B plus 12, that is equal to 4 times y over 2, right? So now if we subtract these two equations, 12 is equal to 4y over 2, which is 2y minus 2x, right? So we have 6 is equal to y minus x, or x plus 6 is equal to y. So now we can plug this back into y is equal to 16, and we get x times x plus 6 is equal to 16. We can factor this quadratic. X is 2, x plus 6 could be 8. So now we have x is 2, y is 8, right? So we can replace that. So now we have 2. This BC here, this length is going to be 8. But it's not asking for what AD or BC is. It's asking for DC. So we need to do one more step. We need to shift this AB over. So we're going to shift this AB over. So it's like a rectangle here. So that's 4. This is a right angle here. We can bring this 2 down here because it's a rectangle. 2. We have this whole thing is 8. So this has to be 6. And now we have this right triangle here. So we can use the Pythagorean theorem, which means DC squared is equal to 4 squared plus 6 squared. We take the square root of that, and we finally get the answer of the square root of 52, which in other words is 2 times the square root of 13.
So that was the end of the chapter 12 side problem.